So for part 3, we're going to have a look at this mole diagram. So this is a short, concise way of trying to move between mass and moles and numbers of particles in a fairly easy manner. So you can use this way or the previous way. This way is probably a little bit easier. Let's have a look at it. So in the center of our diagram, we're going to have the mole. And up in the top left, you can see mass. And what we're going to do is we're going to create pathways from mole to mass. So if you want to go from mole up to mass, so if you're giving the mole, so if a question says to you, you have 0.5 moles and you want to know what's the mass of that, well then what you're going to do is multiply by the molecular weight or the molecular mass, MR. And we'll do some examples of this. If you are at mass and you want to turn it into moles, you go the opposite direction. So if you're going from mass in grams to moles, you're going to divide by the molecular mass by MR. And the one over here is volume. We won't be using that for the moment. We'll be coming back to that at a later stage, and that's volume in litres. Down the bottom, we have numbers of atoms or molecules or particles, depending on what you're dealing with. And again, we'll fill that in as well. There's going to be arrows going up to volume, and there's going to be arrows coming down from volume, which we'll do at a later stage. And also here, if we're going to go from moles to numbers of atoms and molecules, there's a way of doing that. And if you want to go the opposite direction, there's a way of doing that as well. But the one we're going to concentrate on at the moment is the mass and the moles, and let's figure out how to do it. So let's take an example. So first question, how many moles are there in 36 grams of carbon atoms? So always in these questions, you'll be asked a question. So how many moles? So you're looking for moles. You are also going to be given some information. So we've been given 36 grams of carbon atoms. So over here, this is what we want to find. That's our question. We need to be at moles. Here, 36 grams is mass. This is the information we're given. So we're at 36 grams. So we're starting here at mass, and we want to go down here to moles. So how do we go from mass down to moles? You do this. So going from mass to moles, in that direction, you've got to divide by the molecular weight. So when we come back down here to this question, we have 36 grams divided by the molecular weight. So again, you're starting here at 36 grams. So let's say you're here at 36 grams. The compound we're dealing with is carbon. So you've got to go from 36 grams down to moles. So you've got to divide by the molecular mass. The molecular mass of what? The molecular mass of carbon. So it's going to be 36 grams divided by, and you find the molecular mass of carbon on your periodic table. So the way we write that down here is 36 grams divided by 12. Now, that there is your mass divided by your molecular weight of carbon. If this was the molecular weight of sodium, you would be dividing by 23. So 36 divided by 12 then, which is easy enough, that's 3. And it's 3 moles, because that's where you're going to end up. If you start up here at mass and you divide by the molecular mass, you end up here at moles. And that's how to use the diagram. And the same thing applies when you're going the opposite direction. So that's 3 moles. So let's have a look at this next question. How many moles of water molecules are there in 117 grams of water? So it's really important that you identify what you have. So this particular part here, this is our info. We have mass. So we have that. That's where we're starting. The question is asking for how many moles. This is where we want to end up. So we have mass, we want to get to moles. If we have mass and we want to get to moles, again, we've got to divide by the molecular mass. So our mass is 117 grams, that's at the top. You're going to divide by the molecular mass and the molecular mass of the substance you're dealing with. So the molecular mass of the substance you're dealing with is water. So again, water is H2O. So what's the molecular mass of H2O? So H2O is 2 times 1, so 2 hydrogens, plus an oxygen, which is 16. So the total mass is 18. So it's 117 divided by 18. So 117 divided by 18 is 6.5. So again, the answer here is 6.5 moles. So identify what you have and where you need to be, and then use the diagram to figure it out. Let's try another one. How many moles of sulfuric acid are there in 12.25 grams of sulfuric acid? So again, identify what you have. We have this, which is our mass. So we're starting at the top. We're asked to find how many moles. So we need to get to the moles part of the diagram, and we have our molecule H2SO4. So it's going to be 12.25 grams divided by the molecular mass of sulfuric acid. So sulfuric acid we have to work out on the side. So it's H2SO4. So to work out the molecular mass of this, it's 2 times 1, 2 hydrogens, plus a sulfur, plus 4 oxygens. So we go find our sulfur on our periodic table, which is 32, plus 4 oxygens is 4 times 16. So that equals 2 plus 32 plus 64. So that equals 98. So there's your molecular mass. So you're going to divide by 98, and that's going to give you the number of moles. So 12.25 divided by 98 is 0.125 moles. You have to put the word moles in because it's a unit of measurement, 0.125 moles. And again, all of this information that you see here, all of this has to be given in your Leaving Cert. You can't leave any of this out. All of this here is going to be worth marks to you. That's pretty much it. That's moving from mass to moles. You can also move the other way from moles to mass. Let's have a look at a couple of examples of that. So looking at the next couple of questions, this time we're actually going to move from moles up to mass. So let's have a look at our diagram. So on our diagram, if we want to move from moles to mass, we're going to be doing this. We're going to be multiplying by the molecular weight. So multiply by the molecular weight to get up to mass. So let's go down and have a look at our question. So first question, what is the mass of 0.6 moles of carbon? So with this question, you have to again identify what you have. This is our information. We have 0.6 moles. This is where we're at. What is the mass? So this is where we're trying to get to. So you take your moles, which is 0.6, and you multiply it by the mass, the molecular mass. So up here, you're at moles, you multiply by molecular mass or molecular weight to get up to grams. So what is the mass of this? You're dealing with carbon. So what's the molecular mass of carbon? So MR of carbon is 12. So it's 0.6 multiplied by 12. And that works out at 7.2 grams. And again, get the units right. We're asked for what is the mass. So this is our moles multiplied by molecular mass from the diagram gives you your mass in grams. Let's have a look at the next question. Do it the same way. What is the mass of 8.5 moles of water? Again, this is what you're starting with. You're dealing with water, which is H2O, and we're asked to find the mass. So to find the mass, it's going to be the number of moles, 8.5, multiplied by the molecular mass of water. So we've got to work out the molecular mass of water on the side of our page. So again, we've got 2 times 1 plus 16 for oxygen gives us a total of 18. So we're going to take 8.5 and multiply it by 18. So 8.5 multiplied by 18 gives a total of 153. So again, this is 153 grams, and that's the mass that we're looking for. So again, moles multiplied by mR equals the mass. And again, just in case you can get it, where did I get that from? Moles here multiplied by the molecular mass gives you your mass in grams. One last question on this stuff. What is the mass of 0.125 moles of Al2O3? So again, same thing, 0.125, which is your moles, multiplied by this. So mR of Al2O3. Now you should recognize Al2O3, that's aluminium oxide, which you used in your experiment back before Christmas. It was a dehydrating agent. So we've got 2 times aluminium. So 2 multiplied by, you go back to your periodic table, you find aluminium. Aluminium is here, 26.982, so we'll mark that as 27. So it's 2 times 27, plus 3 oxygens, which is 3 times 16. So 2 27s, that's going to give us 54, plus 48 for 3 16s. So that gives us a total of 102. That's your molecular mass. So when you multiply 0.125 multiplied by 102 gives us 12.75. 12.75, and this is grams because it's asking for what is the mass. So that's going from mass to moles and moles to mass. The next thing we're going to look at now is going from moles to particles and particles to moles. Now, in order to do that, we're going to have to finish off a little bit of the diagram. So at the moment, we've looked at this top part of the diagram. Now we're going to look at the bottom part. So for the bottom part, it's actually, again, very straightforward. In the bottom part, if you want to go from moles down here to number of atoms or molecules or ions, depending on what it is you're dealing with, you're going to multiply by, then in brackets, 6 by 10 to the 23. Now you've seen that number before. That's Avogadro's number. If you want to go from the other way, number of atoms or molecules, and you want to go back to moles, you're going to divide by 6 by 10 to the 23. So going from moles down is 6 by 10 to the 23, and then going the opposite direction, you're going to divide by Avogadro's number, 6 by 10 to the 23. So let's have a look. Let's take the first example. So there's a good few in this. Take your time with them. How many atoms of sodium are present in 0.25 moles of this metal? So let's have a look. Identify again what we've got here. We have how many atoms. So we want to be at the atoms part. And again, what I'll do is I'll just draw that section here. So atoms, particles, that stuff, just so we don't have to keep scrolling up. And if you want to go this way, you've got to multiply by 6 by 10 to the 23. And if you want to go the opposite direction, you divide by 6 by 10 to the 23. So how many atoms of sodium are present? So we want to be down here. So have we got the number of moles? We do. We have 0.125 moles. So it's 0.25 moles, because that's where we're at, multiplied by 6 by 10 to the 23. So again, this is something you just put straight into your calculator, and that gives you 1.5 by 10 to the 23 atoms, because we're dealing with sodium. Okay, we'll continue the next question in part 4.